So the next topic is electric field lines. Students, we have already studied about the electric field intensity and the electric field. So because we need to show them geometrically on paper, so we take the help of some imaginary lines which are called the electric field lines. And these lines are helping us in finding the direction of electric field intensity at any point due to any charge. So if I have to go through the definition, so the definition will be that these are the lines or curves drawn around the charge such that tangent at any point on them gives the direction of electric field intensity at that point. So that means suppose I am having any charge Q and there is any electric field line around it. So at any point, if I need to find out the electric field intensity here, so I will be drawing a tangent at that point and will get the direction of electric field intensity at that point due to this charge. If the point of observation is somewhere over here, so I will be drawing the tangent here and will get the direction of the electric field intensity. Now we have done through the definition of electric field intensity that the electric field intensity is always having a direction which is away from the positive charge and always towards the negative charge because they are the central forces. So these kind of things are going to help us in studying the properties of electric field lines. So now let us see the first property, that is these electric field lines, they originate from positive charge and they terminate at the negative charge, which is actually obtained from the definition of electric field intensity. Suppose I am having a isolated positive charge. So as per the property says that they always originate from the positive charge. So electric field lines will always be like this. They will be originating from the positive charge and will be going outside it, right? And if I'm having an isolated negative charge, so the electric field lines, they will be coming towards it and they will be terminated at the negative charge, right? So these are the cases of the isolated charges. Now if I'm having a pair of positive and negative charge, which we'll be studying again in further topics, that this is also if they are equal and opposite, so they are known as the dipoles. So electric field intensity, electric field lines, they have to start from the positive charge and they have to terminate at the negative charge. So when they are placed together, so this field line will go like this towards the negative charge, right? Next is, this is how we can complete it. So these are the electric field lines. So in a way we can show it like this. So here, because they are unlike charges, they are being attracted towards each other, so we can explain it with the help of this electric field lines, right? Now let's move further for the second property. The second property says that no electric field lines can intersect with each other. Let us take an arbitrary case that, for example, let us suppose that we are having two electric field lines, right? And they are intersecting with each other. Now, as per the definition, the tangent at any point gives you the direction of electric field intensity, which is a vector quantity. So at this point, I can draw two tangents. One is this because of this electric field line, and one will be like this according to this electric field line. Now, same point is showing two different electric field intensities directions, which is not possible because electric field intensity is a vector quantity. It cannot have more than one direction, right? And the third point, the third property is discontinuous curves in electrostatic condition, that they do not form the closed loops. That means these lines are not forming the closed loops. Suppose from positive to negative, so the electric field line is moving from positive towards the negative. So they are originating from positive and they are terminating in negative. In any case, it will not happen that it will go from the negative charge and will terminate at the positive charge. This is not possible because they are the electrostatic forces, these are the conserved forces. They are they have the conserved nature, right? So moreover, we have just done in the first point that they originate from the positive charge and then terminate at the negative charge, which is never the case that the negative charge will have the electric field line originating from it. So since they cannot form a closed loop, so this property says that they are actually the discontinuous curves in the electrostatic condition, right? Next is they contract longitudinally or lengthwise when we are having the unlike charges. So the same case when we are having unlike charges, so they were contracting towards each other, right? Because otherwise they would have gone this way. But now when they are placed together, so they are contracting longitudinally, or we can say that lengthwise they are contracting. And on the other hand, if we are having two like charges, so they will be putting the lateral pressure on each other. Now in case I am having two positive charges placed together, so they are the like charges, so they will be like it is going this way, so it will be also going this way, right? So now there must be some field line which is going this direction, and it is also having one electric field line which is going in this direction. Now both of them will be putting some pressure on each other. As a result, this will go like this and this will go like this. So they are putting a pressure on each other at this point, right? Similarly, this will go like this and this will go like this, right? And there are the curves, right? So they are putting the lateral pressure on each other. Next is they do not pass through the metal. This we have done in the previous topic, that metals, they are not having electric field intensity. So since there is no electric field intensity, there cannot be any lines or curves drawn so that the tangent gives any direction of the electric field intensity at any point inside the metal. And the last property, which is it is perpendicular to the metal surface, it is also as per the properties we have already done. In case they are not perpendicular, then any angle if they are having on the surface of the metal, then there will be some tangential component which will be actually going contributing towards the flow of the electrons, and which will result in the non-compilation of this situation of the electrostatics. So these are the various properties of the electric field lines.